So in this session, what I'm going to talk about is there are tons of metrics being collected by various components, not only on Exadata, but on the traditional system as well. But on Exadata, there are many more storage level metrics being collected, and all the DBAs are having access to those metrics. So how we can utilize those metrics as well to solve performance issues or doing like any kind of capacity forecasting. So I'll be talking about the Exadata architecture at high level, just to make a segue into the topics which I'll be discussing later on about the use cases. Okay. Let me. Okay. So once again, give me. Okay, about this session. So what are we going to discuss in this session? Whatever the talks you guys heard so far from my colleagues, this is extension to what they have talked about scale, the requirements, the growth of the database platform. How are we basically integrating different parts of the requirements into our database platform and providing the best availability to the business. Now, I'll start off with like an introduction to about myself and PayPal, and then we'll get into like a unique characteristics of PayPal database platform. What is that which is making PayPal database platform very unique in nature, and then we'll get into Exadata architecture. I'll just keep it at high level because that's not the main topic of this presentation. But before we get into 4 and 5, it's good to have high level understanding, even though you're not working on Exadata. I'm sure like some of the points will be can be used in your non-Exadata environment. This is more about the methodology, about the process, how you find out the opportunity to achieve more efficiency in your environment, just not in the database environment, but in overall stack, right? And then we will talk about the storage metrics and which are more relevant to the DBAs, and how you can understand some of these metrics because there could be like tons of things at storage layer, but how do we understand, how do we make a sense out of those metrics and use those for solving the problems? Going to the next slide about myself. I've been part of database team for more than a decade now at PayPal. I've been working on a lot of different challenges, a lot of different implementations, and various other business projects. I've been working on Oracle database technologies for over 15 years now. I have implementation as well as operational experience on earlier version of Exadata, and then recent ones are X7.2s, X8.2, and X8M2, which is where the persistent memory was integrated in Exadata. And then this will also give us an opportunity to discuss about PMEM, how Aerospike is leveraging PMEM versus how Oracle Exadata is leveraging PMEM. And then I'll show you some of the things about how PMEM is helping us improve the overall database platform performance. Right? And then I've been like part of PayPal team and worked on various projects related to scalability, availability, performance tuning. So I'm really passionate about taking things from ideas to implementation and troubleshooting, solving complex performance problem, scaling, availability, all kind of things related to database platform. Okay, so a little bit about PayPal. I know my colleagues also mentioned about what PayPal does, and I know everybody is aware about what PayPal does, but PayPal is into digital payment space. PayPal has been pioneer in this digital payment space. And PayPal's mission is to democratize financial services for everyone around the world to so that they get an opportunity to participate in this thriving economy. with pandemic, e-commerce has been on the rise, and with that, PayPal has become more relevant, and it has become a top choice for consumer to pay and merchants to accept the payments. And with that, new products are launched at point of store, where you can pay using PayPal, where you can use like QR code or buy now, pay later, and those kind of functionalities. And the unique about PayPal is PayPal has been growing like at very fast rate. I mean, in last 1 year, it has grown at very rapid speed, and with that, our database platform and infrastructure has also grown. Right. So we'll talk about some of those unique challenges we are facing at database platform. Now, what are those unique things about PayPal database platform? We have various kind of data stores, starting from Oracle, MySQL, some of the NoSQL databases, Aerospike, and homegrown key-value database. So all of these data stores are actually critical for us because they are helping our business to basically be available all the time, and database being like a core component of whole infrastructure. We want to provide like best availability and best performance to business platform. Oracle is playing a critical role in our database platform. We have been using Oracle RAC, Active Data Guard, Golden Gate for various reasons like scalability, availability, performance, and with like a recently we got Exadata as well, X8M. So we have more than like 100 plus databases running on Oracle RAC. And we are also getting into cloud. So our Dev QA integration database are running on public cloud. And just want to take this opportunity, if you are like if you are excited by this, we are actually looking for talented engineers. So if you are like expert at any of like this database, please reach out to us. Okay, so now let's get into the topic. So before I get into the actual part, I just want to like give a quick overview on the Exadata architecture. People who have not worked on Exadata, I'm sure like this is not that complicated to understand at high level, but if you are going deeper into understanding like the role of each component and how well they are integrated, that's where it gets a little bit more complicated. But just to keep it at high level, Exadata is an engineered system which is having storage, network, compute, all integrated within the same rack, right? Obviously, like you have options to do like multi-racking as well if you have more capacity demand, but traditionally it is a rack within which you have everything you need to run your databases, right? So in this talk, I will specifically talk about X8M. It's a persistent memory flavor, which is basically 10x faster than the previous generation, right? In terms of latency and throughput also. So Exadata comes into three different flavors. One is, two different flavors. One is in high capacity. There you have PMEM, persistent memory, flash, and NVMe flash, and then you have obviously the SAS-based disks, right? And the extreme flash, you have two tiers, storage tiers. One is like PMEM, and then the other one is NVMe flash. But with NVMe flash, you will get lesser usable storage capacity, but you get like very consistent performance, right? So it's a trade-off. Now, in order for now that like your storage cells can provide many more IOPS than the previous version, and it can also provide high throughput for the high throughput oriented workload. The network could become a bottleneck, right? So in the previous generations, you had IB switches, IB fabric, which was 40 gigabit. Now Oracle has introduced 100 gigabit and also improved the RDMA protocol, which is basically remote data access memory, which is being used to access the data directly from the PMEM from the storage cell. So just to give an example, like if the database session is asking for a data, and if data happens to be there on the PMEM on the storage cell, then it can be directly accessed without involving like IO call, so that it can achieve the best performance and utilize the less CPU cycles, which could be used for like some other activity, right? Let me go to the next one. Just want to mention one more thing on this slide is like in the traditional non-engineered system, you have compute, a network, and storage. Like all of those are like isolated components, and then they are put together by the customer, right, to make look like a one unit, and that's where you run the Oracle database. But here it's all integrated, and software, Oracle software also is all well integrated and can leverage some of the efficiencies, some of the security features which are part of the hardware or chipset. Okay, so this is a storage architecture, like how Oracle is basically leveraging RDMA and how it is leveraging this different tier of storages, right? Now, a PMEM is obviously, it is persistent storage. Now, the data can be, like data will be persisted after the reboot. So now the use cases will be many more of PMEM, as you have seen, like for Aerospike, it is using for indexing, right? So here also the same thing. Not just for the indexing, but this is like becoming a caching layer, and it can provide the fault tolerance, right? And all of those good benefits. Now, for accessing the blocks from PMEM from the database server, the latency is less than 19 microseconds, which is like phenomenal, right? If you access the data from flash and NVMe flash, it is anywhere between like 100 to 200 microsecond, right? But here it is 19 microseconds. So you can imagine the power of PMEM and how well integrated in the Exadata and the softwares, right? And this is like very useful for the background processes, like where, let's say, your log writer has to flush the redo when the commit happens to persist the data. Now, for those kind of activities or those kind of background processes are leveraging PMEM flash very efficiently, so that your commit time from the application side could be very fast, right? And you will see the benefits on the application side. Now, the next one, now you have, so here again, like we are talking about Exadata HC, high capacity, where you have the disk, right? Now you have so many storage tiers and so many cache tiers, like you have your SK buffer cache on the database server, and then you have a PMEM, then you have flash cache, then you have disk, right? So how do you know like where the data is being read? Like, let's say you are running a query and that is asking for, like, let's say 10 different blocks. Now, how do you know like which block came from which tier, right? And it is also possible that, like, let's say one of this block does not exist in any of the cache and the read has to go to a disk, right? Now, the overall query performance will be determined by that lowest device. Now, how do you know like where the data is being read from or being written to? This is like for writes, Exadata is leveraging the PMM and flash cache very efficiently. So writes, you will not see like a problems on the writes in the normal situations. But for the reads, especially on HC, if you are like accessing data randomly, like if your application is accessing data randomly, then if those data sets or those blocks are not in the memory, then how do you like, or in any of the cache, then how do you find out like where it came from, right? And how can you tune it, first of all, like how can you identify and how can you tune it to make it better and then have like a consistent performance, right? It's about the performance as well as the efficiency, because at scale, if you are having like a big database platform, and you will look for the opportunity for efficiency, like whether you get 2% of efficiency or 10% efficiency, because it's not just about the database. You have like a whole application stack. If your query is taking longer time, that means all of those resources which are submitting those requests will also be waiting, right? So you want to find out like all the opportunities where you can tune your configuration or your queries and to achieve that efficiency, right? Now there are a lot of tools and there are a lot of log files, a lot of traces getting collected on traditional Oracle system as well as on Exadata, right? Now what are those different tools? And I'm sure like everybody's aware about like all of these tools, where we have AWR reports, then we have active session history, and just FYI, that requires like a diagnostic pack license. And then you have bunch of trace files getting generated. You have Exawatcher data. You have bunch of metrics being collected on the storage cell. So these are like some of these are like integrated with each other, and some of them are like isolated, right? So like let's say if you want to take data from Exawatcher, which is basically collecting the data by running OS level commands, like, and how can you connect the data points from there to, let's say, $V active session history, right? So when you are troubleshooting a performance issue, then it is very important that you collect the data from every single component and then collect them together. Put together and then connect those data points to make sense out of it, right? And to understand what could be that which is causing the problem. Now, one thing on this slide I want to mention is the Exawatcher data. So that's all raw data, but there is a like nice utility, Exawatcher results.sh, that can help you graph out all that Exawatcher data so that you don't have to go through like a raw data, unless you really like to stare at the black screen. Okay, so here I'm just going to share like some of the data points from our environment from X8 system. So as you see here, I was mentioning about the log writer performance, right? So the log writer performance, as you see here, the average response time is less than 17 microsecond, which is like less than what Oracle has published, and this is phenomenal, right? Like we see that the writes are getting, log writer writes are getting completed in 17 microsecond, and this is because we have premium based Exadata, right? And then you can look at the histogram here on this side. I'm not going to go in all those numbers, but you can look at the average number. Now, cell single block physical read, which is around 158 microsecond, right? That's also great. Now, if you look at this particular section, you can see like how many reads are being satisfied by PMM, and then flash, and then how many reads are going to disk, right? So I just put some summary here, but if you look at it here, the PMM can be accessed two ways. The most efficient way Oracle is accessing it is using the RDMA, and the ones which cannot be read through RDMA, they are going through the normal IO calls through interconnect, which is SKGXP layer, right? But you can see that more than 95% of them are going to the PMEM and flash, but you still have like some reads which are going to our disk, and you want to find out like whether you can do anything in order to have like 100% PMEM and flash cache hit to get the consistent performance, right? Now, the thing is like all the components in Exadata are designed for fault tolerance, meaning that like if you have one component failure, like let's say you have a storage cell which is failed. Now, how can you how would you get like a consistent performance even though there's a failure? So some of these things are like mirrored across multiple cells, and that's where like you can imagine as like ASM high redundancy, right? So whatever is happening on the storage layer, on the storage cells, that is also mirrored, so that if there are failures, you still get like you are not seeing the performance impact from the database standpoint. Okay, so and then AWR is actually collecting a bunch of other statistics as well, and you can see like a PMEM cache related statistics, the configuration, how many reads are going there, writes are going there, how many internal reads are happening, how many internal writes are happening. You also have a section of Exadata outliers, where it is possible that like some of the cells or some of the disks are causing the outliers in the system, right? So take a look at it. Take a look at the AWR Exadata AWR report. There is like tons of information there, and a really good useful information there to understand how Exadata is basically leveraging these different components, right? Hardware components. Now, what I want to get in is like, this is all great, right? I mean, the average is great, but can average represents everything? It does not, right? Like you will have some outliers, even though you see that like there's nothing like which is outstanding, but when you look at in detail, you will probably find out like there are certain type of calls which are actually taking longer time. That could be because like your applications access nature. It could be like accessing data from all over the place, and it is possible that it is not there in the cache, right? But how can you make sure that like or what are the different methods you can implement in order to have that consistent performance? Now, here, like this is where Ash will come into picture, right? And whatever I'm sharing here, this doesn't mean that like the Exadata system is not performing well. What this means is like the slowest or the IOs which are taking longer time, those are captured in the hash. So like as I said earlier, like 99% of the time, all the calls are going to flash, but 1% of the time, or less than 1% of the time, where the calls are going to disk. How would you identify, and what would you do in order to find out what is the root cause of that, right? Not necessarily a system problem, but it is just like how can you tune your application, or what you can do on the back end so that it does not cause like many outliers, right? As been shared in the previous slide about the ILM, like how we are identifying the data heat map, and then how we pin those frequently accessed segments into the memory in the PMEM and flash cache, and all of those are different techniques of making sure that we get consistent performance, which I'll talk about later in the slide. Now, if you look at here, I've just like got out from Ash to show that like here in the top section, you see the output by cell, right? So we have 12 storage cells, and what is the average latency you are seeing, right? And this is just for the captured samples, and like 95% of the samples will not be captured because they are getting completed in in microseconds, right? So these are the ones which are running longer because the reads are probably going to the disk. Now, like, how do we take this further? How do we find out like what is happening here? And so let's go to the next slide. Now, here what I want to show is some of the time, or most of the time, like a lot of information we need in order to troubleshoot this kind of problems, the information is already there, but we just need to loop and connect the dots in order to derive the hypothesis, right? Or to derive the root cause of the problem. Now here, if you see, and this is something like I was not using personally before, but like like we were trying to solve some of the performance issues we have seen, we got to learn more and more, and found out that everything is there, but it's just that like we need to know where those things are and connect those dots, right? So one of the thing here I want to highlight is a lot of times, like some of the basic tracing is already on. So if you look at if you connect some of the data dictionary views, you will see all the useful information in one place, and here you see the trace file name, right? Now what this tells me is like, okay, let's take a look at this trace file, because there could be something logged there about this particular call, right? And that can probably reveal something which is happening in the database or at the storage cell layer or at the network layer, right? Now, this is what I see in the trace file, like one of the trace file, which is, sorry, which is shown here, is that, you know, this is like if you go through this line, you will see that there is some error which is happening, right? So this could be timeout at, like, let's say network layer, or something on the storage cell when accepting this request coming from the database node, right? Now here we see that, oh, there is some error happening, and probably we won't be able to know, like because we don't have access to the code, but at least we can understand that, oh, there is some problem happening here, and that is that could be the root cause. Right now you can submit, like if you have access to Oracle support, then you can provide this evidence, right? So that the resolution can be faster. And a lot of times, like we can also, like, let's say, depending on the utilization of the resources, but like let's say you are running like very CPU bound workload, and your system CPU utilization is very high, then you can see from here as well, right? Like if the interrupts are not taking place, or the background processes are not getting on the CPU on time, then all of this problem could happen, right? So, but here, just to illustrate the what I'm talking about is, like in this trace file, like we found that, oh, there are timeouts. I don't know, it's like 14 times. That's something I don't know, but I can say that like it took almost 67 milliseconds, right? And this is a problem, right? Now, if I want to correlate this data with, like, let's say, what is happening in Exawatcher. Now, Exawatcher is like very useful utility. It has multiple modules. It is collecting bunch of data very frequently. And one of the things here I found is, like, let's say, timeouts, right? And then that indicates that there could be some timeout at the network layer. So let's look at the RDS info, which is basically the protocol being used for communicating with the storage cell, right? So I'm just looking at the RDS raw data and just looking for any samples which have taken like more than 10 milliseconds, and I see that, oh, there are some RDS calls which are taking more than 10 milliseconds, right? Now, here from the database side, like we are seeing that IO is taking time, but now when we drill down further, we see that network is taking time, right? And obviously, like the timestamp won't be matching here, because this is just like I captured the data from the different time. But this is indeed happened, and I don't have like all the data captured from that incident, so I had to like take the data from different time here. But the point I want to make here is like develop your like own troubleshooting process, and follow that, and look at like every single component which is collecting the useful data to basically understand more and more. Okay, so now from here, like where do we go, right? So whatever I have shown so far is like coming from the basic tracing enabled by default. But like if you want to have more concrete evidence of like what is happening, right now, we need to enable like extra tracing, but make sure that like you have blessings from Oracle. And, without that, don't run like any kind of excessive tracing on production, because it could impact your whole database. Like here we are just trying to fine tune that last 1%, but running this tracing, and if it is causing like excessive log generation, then could impact like your production workload, right? 100% production workload. So be careful about that. But this is one of the good Moss note where I found that like you can enable the tracing for the outliers to find out more about that particular outlier, like what exactly is happening, right? And then obviously like Oracle is self-documented in the sense that like you can see a lot of things from the database itself, right? Like let's say you do Aura debug and see what kind of tracing options are available, and from here like I see that there's a leap cell tracing which is specific to Exadata, and that can help you trace like Exadata related things, right? Now from my trace file, like what I see is here the read has gone to flash cache, which is supposed to be like serving the data out of flash cache within like, let's say less than 100 microsecond, right?
Yeah.
But is there a question? Okay, so this is going to flash cache, but it is taking 141 millisecond. What could be the reason? Like the flash cache is not that slow, right? So here, when you look at the details about that particular call, then you see like where the time is being spent. Like here you see that last read to completion is taking like 141 millisecond, right? And then some of the time, like because this is like a low level tracing, so the microseconds you see, or the time, it could be a little bit off, but like that is best it can capture, right? Like here if you see it's saying that operation took 141 milliseconds, but here you see like more than that, right? So it is possible that like times are a little bit off, but the point here is you can see that for a storage to serve that read, it took only 50 microseconds. So where is that like additional 90 second is being spent, right? So now from here you can see that there's some other problem, right? And if you are very curious about to know like what is last trip to completion, you can search on Google or like Moss, you will find some references, right? But the point here is like, as you like, in order to basically speed up the investigation process, or to get like, let's say the fix from Oracle, if it is a bug, then the more you do on your side will help getting you to the resolution faster, right? And this can be used for everything else also. It's not just about Oracle, but a similar troubleshooting methodologies can be implemented on various applications. Okay, so now getting into the storage cell metrics. So there's like a lot of text here, a busy slide, but what I want to mention here is you have a storage cell, right, which is basically a kind of a server with a lot of storage. Like CPU utilization, then you have storage there, so the run queue size also matter. How is the memory utilization, because you have some services running on storage cells, which are basically collecting the data or providing, like, let's say, smart scan functionality, doing columnar compression, so a bunch of those things, right? So there are like a lot of processes running on storage cell. Then from the from the disk standpoint, you want to measure the response time, IOPS, throughput, utilization, etc. And a lot of these things are actually collected by OS Watcher and cell serve, which is basically the critical process running on a storage cell. And then you have another service which is called management server, MS, that's also collecting some of the metrics. So all of these metrics are collected there, but it is important to understand like what to what to look for a given particular area, right? So like let's say for flash cache and PMM cache, you have response time, IOPS, throughput, utilization, how many hits you have and how many misses you have. Like let's say the call is coming from the database side, and it is trying to access data from flash, but it's not there. So that's like a miss, right? And then it has to go to the disk. So you can also measure like hits and misses for each of these components. Now, some of the metrics are like cumulative, meaning that like ever since those services started on those storage cells, it will accumulate, and some of them are like point in time, like rated. Like let's say you want to see IOPS, right? So when you do query, it will show like at that point in time, and it is. I mean, some of these things like are applicable to the non-engineered system as well, but will not be in the same format, or probably we will not have access, right? Because in the traditional system, you have like very specific role for taking care of those individual components, right? So now for in the traditional system, you will have a system admin who is doing some of these things. But now that on the Exadata, like DBAs are having a more visibility into like each of those components, you can also take a look at some of these metrics. Now, the Exadata is basically they have implemented the QoS, a quality of service, really well. So it can identify like which write is critical versus which write is not critical, right? And they can prioritize those calls based on the priority, and serve the IO calls really well to have like a better performance for critical applications. Now, on Exadata, the IOs are basically divided into two categories. One is like a small IO and one is a large IO. So for OLTP kind of workload, you will have small IOs, and those are given like more priority versus like large IOs, which are more than 128 KB, right? Where that is, and then if you see like very high large IOs, that means like coming from your application, that means your application is throughput intensive, meaning like it reads a lot of data, and like in those cases, like smart scan or like some of those Exadata related features will kick in and help with the performance. Now, the last point is you have cell CLI, DCLI utilities on Exadata, which could be used for like collecting the metrics, and like running like any kind of command, like let's say from DCLI, if you want to, let's say, just check the load of the system, all the cells, you can just run the DCLI from one, and then provide the cell names, or like if you have a file, you just provide the file name where all the cells are listed, and then you can specify your command, and then it will get you the output on one screen, right? So this is where the DCLI is very handy. It can help you like reduce some work. Okay, so now here I have put together some commands, but the intention is not to basically memorize this command, but just to show how we can explore all the metrics, right? Like how we can get familiar with some of these commands quickly, right? The first command is help, and when I log into like any kind of utility, the first command I run is like help, if I'm not familiar with that utility, right? Because that will give you a good understanding about the commands and the usage of those commands, right? So on Exadata, cell CLI, like like when you do help, it will show you bunch of those topics, and then like you can start picking your favorite topics or the topics you are interested in, and then start looking for the help, right? And then there's a great documentation also from Oracle, which is like going into detail about a lot of this important metrics. But here, like if you are new to Exadata, or if you haven't explored this area, then some of the top commands like help, then describe metric definition, then list metric definition, attribute solve, right? So this will help you get started with some of these important commands, right? Which you can use to collect data for troubleshooting your performance issues, or like for capacity forecasting. The other ones are like the important one which I look for is like, let's say when I see something is slowing down, then you can look at the disk utilization and metric objects in like FD. So this is basically specifically showing the flash cache related metrics, right? Unfortunately, the PMM is very new, so like there are like maybe less than 5 metrics getting collected about PMM. I'm hoping that like Oracle will add more and more in future release, so that we get like same kind of visibility into PMM area as well, because the scope of PMM is also getting expanded within the Exadata as well, right? Now the next one is if I want to see like how many miscounts I am having, right? Like you can literally like put a SQL kind of query and then see like which particular database which is running on that Exadata rack, which particular object. So you can see the object number here, right, which is mapping to the data object ID in DBA objects or CDB objects if you're using multi-tenant, right? So from here you can find out the objects which are not having great flash cache hit, because like the random access pattern, right? And then if you are seeing that like that a particular object is very critical and the performance of that object is very critical for serving the application traffic, then there are certain things you can do, like which I'll share in the next slide. Then as I was saying earlier, like all the IOs are basically divided into small IO and large IO. So if your workload is like IO intensive, then you can look for the small IOPS. And then if your workload is like throughput intensive, you want to take a look at the large IOPS, right? And then regardless, like there are some activities happening on the storage cell itself, like let's say scrubbing, right? That could cause the utilization to go up very high. That could also cause large IOPS. So in general, like you should look for some of these critical metrics and just try to understand like who is contributing what, right? So that you can better tune it. And then the last one is so there are like hundreds of these commands literally, but I just pick like a few of them which could be useful. The last one is metric history. So metric history is basically all the metrics which are being collected, and if you want to take a look at like what happened yesterday, right? For this particular metric, you can use metric history to collect the data points, right? Right now, like by default, the metric is being captured at every 1 minute, but hopefully like that will be changed in future. But right now, like it is taking the snap every 1 minute. So you will see that like between two snaps, you will see like 1 minute interval. I mean, 1 minute is a long duration, especially like when on the database side we are collecting sample set every one second, right, in Ash. So like some of the time, like because of this discrepancies, like you won't be able to match like second to second, but some of these things will give you good idea about the thing which you are trying to do. Now, and then also by default, the metric data is retained for 7 days. So you can query for a given time frame, right? And there are like a lot of metrics, so like always try to use some kind of filter so that the output is limited. Okay, so now the the important part which I want to show you is how do we find out like which ones are taking longer time, like which ones, meaning like which calls are taking longer time, right? And if I want to find out by object, right? Like here in the snippet, like I'm joining Ash and CDB objects because this is a multi-tenant environment. But what I'm trying to find out here is which a particular table is having longer latency, right? Longer average wait time. Now from here, what I can do is like I can take the object ID and go to the cell and then try to query that particular object ID. So if you see here, the 84265 is the one which is having, like, let's say average latency of 219 millisecond, and there are 17 sessions waiting waiting, right, for that particular object. And this is I just like captured like top four just to illustrate like this example. But here you take the object ID and then go to the cell and then find out like how many flash cache misses that particular object is having, right? I mean, it would be good to have the object name itself on the storage cell so that you don't have to go to the database and then get the object ID and then do this. I mean, this becomes like even more tedious when you have a partition table where the partitions are created at different times. So the partition, the data object ID is not like in sequential order, right? There are gaps. So I mean, if you have thousands of partitions, then it becomes really tricky. So it would be better to have like object name here reflected so that you can just give the object name and see like for all the segments which are related to that particular object. But the point here is like you can go and look at how many flash cache misses it is having, how many times it has to go to the disk, right? And now this will give an idea, like if this table is like, let's say, user profile table which is being accessed in every single query or most of the time, then you want to think about like how can you provide a better consistent performance? How can you bring that whole table into flash cache so that the calls are not going to the disk, right? Now one way of doing that is you can pin the segment. A segment could be like partition or subpartition or index partition, subpartition. You can pin those segments with the self flash cache key, right? But right now this is for the self flash cache, but not for the premium cache. And I'm hoping that like we have like multiple layer of caching. So once, like if the data is already there in your buffer cache, then you don't have to worry about it, right? But if the data is not there in the buffer cache, then it will try to go to the PMM first, and then it will go to the flash cache and then go to the disk, right? But what this will help you with is like if you pin the segments into the flash cache, then it will try to give the priority to this segment over other segments, right? To keep the data around in the flash cache, so that your calls are always going to flash cache. Now the problem is though, what happens here is, let's say like you are migrating your database from 11.204 to 19C, and you have Exadata there, right? Now the problem is like when you move your application from 11.204 side to 19C side, now because this is the first time your application is running there, so not all the data will be, or not the data which is frequently being accessed by the application will be there. So the very first time when the block is read, it has to read from the disk, right? And you will be paying penalty for that. So like over time, it will, depending on how the data is being accessed, your caches will be warmed up. But initially, like for first call, your application has to pay the penalty. So now how can you basically go ahead and proactively bring the data into flash cache? Now, this is one of the production issue we have seen when we did move our application from 11.204 to 19C. There we have a partition table where what happened is the index is also partitioned, but the query is not like very well partitioned. It is not like leveraging the partition pruning. So now it is going to every single index partition, right? And then going to the table just to check whether the data is existing in the corresponding table partition or not. But now, in order for Oracle to find out like where the data is, like it has to at least perform the like the physical read for the first time, right? Like now, if you are talking about like, let's say, hundreds of index partition, so like it has to issue like, let's say, 100 physical reads, right? For reading like let's say segment header or like a first block. So it will be doing the IO calls, and if those are on the disk, then if you have like very stringent requirement from your application side, like how we have, then it will be a problem. Like your application will start timing out, like if it is taking longer time. And that is exactly what happened in our case, where our query started like timing out after 5 seconds, as you see here, right? And then you see here, it was doing like 323 physical reads. This doesn't mean that like everything was going to the physical disk, spinning disk, but part of this was going to the physical disk, and that actually contributed to the query timeout. But what we did is like we pinned the object, the index into the flash cache, but that's not going to proactively bring the data into the flash, right? This is just saying that like if you are going to access a block, then we will preserve that in the flash cache and will give the higher priority. But this is not going to like bring all the blocks from the disk to the flash cache, right? Now, in order for us to basically forcefully bring all those index blocks into the flash cache and populate in the caches, we have to do like a select, which is like a brute force method to bring everything into the caches, right? So that we get rid of this timeouts. And I think it would be better that if we have a utility where you can just say that bring this particular object into flash cache, right? And obviously like with some control, because we don't want to populate or pollute the flash cache, right, unnecessarily. But that would be like a good enhancement for Oracle to consider, where you can just like provide the object ID and it will bring the data into the caches and provide the consistent performance. And this is just going to be leveraged for like extreme cases where your application cannot basically tolerate the latency and then starts timing out, right? Now, in order for us to like dedicate portion of flash cache to a given database, you can obviously implement the cell level IORM, which is like on the storage cells, the flash cache, PMM cache, all of these are shared across all the databases which are sitting on the Exadata rack, right? Now, if you have some critical databases which needs consistent performance, while some of the databases like kind of like, let's say, not so critical and they can tolerate the latency, then you can implement the cell IORM, where you can dedicate a portion of this caches to a database. And obviously, like it is providing the role functionality as well. So if you have a standby, and like when the database role is standby, then you don't want to have more resources allocated, more cache allocated, right? You can specify the role, and cell IORM basically detects that and then acts accordingly, so that when the database is physical standby, it does not basically just take that portion and just keep it to itself, rather than sharing with all other databases, right? Now, here, like we talked about a bunch of scenarios, like real world scenarios, like what we have seen, and how we are approaching to solve some of the shortcomings This is especially for those 1% of the reads which are going to the hard disk, right? Because we want to have better performance like consistently. And the second point is to find the efficiency, because it's not just about the database efficiency, it is about the whole stack efficiency, right? And at scale, small things matter. Like even though you get 1% efficiency or 2% efficiency, that could save like millions of dollars, right? Depending on like where that area is. But a database being like at the bottom of the stacks, we think that like the better the performance we get from the database, the better the whole stack will be. Okay, so just want to summarize like what we discussed here. We discussed a lot, but I just want to make sure that like you guys have a good takeaways from this session. So the very first thing is like understanding some of this basic metrics, right? Some of this basic metrics are basically measuring and doing the calculation of things which are happening on the different components, and understanding and stitching together like all of these different data points will help you find out the root cause of the issue, right? Or at least help you expedite finding out or getting the fix of that issue. Now, like our philosophy, like at PayPal, like we try to go and look into each and everything. Like even though it is a log file, we know that log file will probably not have like, let's say, some of the metrics, right? Or log file will not have metrics at all. It is just there for like logging like alerts and warnings and ORA errors. But still, like some of those things are really useful in finding out why we are seeing the latency or why we are seeing higher IOPS or throughput, right? And as I mentioned earlier, at scale, everything matters. Like you want to find out like every single opportunity to tune your system so that you can get consistent performance and save some dollars. Now, from the DBA point of view, one important thing like which I practice all the time is understand every single column which is there in VDollar active session history and VDollar session. This will help you with the troubleshooting a lot, and this is especially useful when you are like when your issues are lasting for like a few seconds, right? And if your business cares about like every second availability, then this will certainly help you guys to answer some of the questions your managers or your leadership is asking about the issue, right? And then the last thing is establishing the performance investigation procedures. I know like every issue is unique in the nature, but at least like having some sort of procedures and making sure that every team members understand each and everything what you put together in the procedure will help you respond to the site issues. When I say site issue, meaning like, let's say if you are having a performance issue and your business is taking impact, right? I mean, long-term solution could be totally different, but how can you resolve that particular issue at that moment and then bring the site back to the normal state? So establishing these good procedures for performance investigation, or for that matter, like any kind of issue, like having good process and procedure will help you quickly respond to the issues. With that, like I'm done, but if there are any questions or if you guys want to have like more discussion on any particular topic which I mentioned here, I'll be happy to answer those questions.